Welcome back, students. This is the session 7 from the playlist of wave optics. The topic is interference of light, and today I will be discussing about this phenomena in brief. And for that purpose, I have written down here 3 bullet points which describes this phenomena in brief. So the first this first point is the definition of the interference of light, and the definition is when two light waves emitting from two coherent sources and traveling in the same direction superimpose on each other, then the amplitude and the intensity of the resultant wave is given by these two formulas. That is, the amplitude of the resultant wave AR is equal to under root of A1 square plus A2 square plus 2A1 A2 cos phi, where phi is the phase difference between those two waves, and the intensity of the resultant wave is given by I1 plus I2 plus 2 times under root I1 I2 cos phi, where I1 and I2 are the intensity of the individual waves. So this phenomena is called the interference of light. Here in this definition you will find two words, that is coherent sources. So here I have mentioned or I have written down the definition of the coherent sources in the second point. That is, coherent sources are those sources which emit light of same frequency or wavelength, and the originating phase difference between the two waves is either zero or constant. So when the two light waves emitting from the two coherent sources, that is, these light waves are having the same frequency or wavelength, and their originating phase difference is either zero or constant. So when they superimpose on each other, then the amplitude and the intensity of the resultant wave is given by these two formulas. Third point, this phenomena, that is the interference of light, is either constructive or destructive. That is, the interference is either constructive interference or destructive interference. The constructive interference produces the bright fringe on the screen, and we will be discussing about it in the subsequent sessions in detail. So here I have just written the in brief that what constructive and destructive interference is all about. So constructive interference produces a bright fringe on the screen, and the phase difference in the case of constructive interference is 0 or 2n pi, and the path difference is 0 or n lambda, where lambda is the wavelength. In the case of the destructive interference, the phase difference is equal to 2n minus 1 pi, and the path difference is equal to 2n minus 1, that is in bracket, multiplied by lambda by 2, where n is an integer, that is n can be 1, 2, 3, 4 and so on. So in the case of this destructive interference, we get the dark fringes on the screen. There is one important formula, that is phase difference. The phase difference, you can write it as phi here. This is also equal to 2 pi upon lambda multiplied by the path difference. So this was a short description about the constructive and the destructive interference, and now let us first of all discuss about the constructive interference. And here in this topic I will be finding the resultant amplitude and the intensity of the resultant wave. So the amplitude of the resultant wave in the case of constructive interference will be equal to A1 square plus A2 square plus 2A1 A2 cos phi. Now here in the case of constructive interference, the phase difference is 0 or 2n pi. So if the value of cos 0 will be equal to 1, or in fact cos 0 or cos n pi, cos 2n pi. this will be equal to 1. If you put the value of n is equal to 1, the value of cos 2 pi will be equal to 1. If you put the value of 2, n is equal to 2, then you will be getting this cos 4 pi. Now cos 4 pi, the value of cos 4 pi will also be equal to 1. Similarly, the value of cos 0 is also equal to 1. So the resultant amplitude will be equal to A1 plus A2. Now let us come to the resultant intensity. So this is equal to I1 plus I2 plus 2 times under root I1, I2, and cos phi, or the value of cos phi is equal to 1. So the value of the resultant intensity will be given by this formula in the case of constructive interference. Now let us discuss about the destructive interference in brief. So this destructive interference, the phase difference is equal to 2n minus 1 pi. So if I put the value of n is equal to 1, so I will be getting the phase difference as pi. So the value of cos pi is equal to minus 1. If you put the value of n is equal to 2, you will be getting here as 4 minus 1, that is equal to 3 pi. So cos 3 pi is also equal to minus 1. So we can say that the resultant amplitude in this case will be equal to A1 square plus A2 square minus 2 A1 A2. So, and because this is the under root, so this can be A1 square plus A2 square plus 2 A1 A2. This is basically equal to under root of A1 plus A2 whole square, and therefore it was equal to A1 plus A2. Okay. Now similarly here in the case of destructive interference, the value of cos phi will be equal to minus 1. So we will be getting the resultant amplitude as A1 minus A2. The resultant intensity will be equal to I1 plus I2 minus 2 I1 I2, because the value of cos phi in the case of destructive interference is equal to minus 1. So in the case of constructive interference, we get the maximum amplitude, that is A1 plus A2, and in the case of destructive interference, we get the minimum amplitude. Similarly, in the case of the constructive interference, the intensity of light, that the intensity of the resultant light wave is maximum, and in the case of destructive interference, the intensity of the resultant light wave is minimum. Now there is one term by the name of amplitude ratio. So amplitude ratio is basically the ratio of the maximum intensity and minimum intensity. Now in the case of constructive interference, we are getting the maximum intensity, which is equal to I1 plus I2 plus 2 under root I1 I2, and this is the minimum intensity is equal to I1 plus I2 minus 2 times under root I1 I2. So this is the maximum intensity, and this is the value of the minimum intensity. That is, the intensity of the resultant light wave is maximum in the case of constructive interference, and the intensity of the resultant light wave in the case of destructive interference is minimum. So I have written down the value of I maximum and I minimum from these two equations. Now we also know that the intensity of light is directly proportional to A square. A is the amplitude. The intensity of light is directly proportional to the square of the amplitude. So this equation can be written as A1 plus A2 whole square, and this one will be written as A1 minus A2 whole square. So from here we can simply write, this can be written as A1 plus A2 divided by A1 minus A2 whole square. So the amplitude ratio will be equal to A1 plus A2 divided by A1 minus A2 to the whole square. And in this session I have tried to describe about the interference of light in a very brief manner. Here we have discussed about what interference of light is, and then we have also discussed about the constructive interference and the destructive interference. That is, means what are the conditions for the constructive interference and what are the conditions for the destructive interference. And finally we have also derived the equation for this amplitude ratio. So in the next question, in the next session, I will be taking up a simple question which is based on what we have studied today. So till then, have a nice day. Bye.